Our goal today is to review solving equations with variables on both sides. So last year you should have learned the steps when solving an equation, things you want to look for. The very first thing you want to look for is there a distributive property that needs to be simplified, meaning we have a number outside of the parentheses and we need to multiply all the way through. The second thing we're going to look for is, do we need to collect like terms? And like terms, recall, mean they have the same variables, but they're on the same side of the equal sign. The third thing that you're going to look for is to move your variables to one side, and that is what we're going to focus on today. We don't want variables on both sides. We want to put them all on the same side and all of our numbers on the other side so we can simplify that easily. The fourth step is we are going to undo our addition and subtraction by using our inverse property. And last thing that we're going to do is we're going to undo the multiply divide, again using that inverse property. So what we've got here, we've got a little situation we're going to look at to go through these steps to simplify. It's talking about Future Engineers of America raising money for a field trip. The club members will hold an engineering contest to raise the money. They're going to decide, are they going to have a straw bridge contest or a card tower contest? The straw bridge contest will cost the club $5.50 per competitor plus $34.60. It's really important, based on what we talked about yesterday, that you're making sure that you are diagramming your sentences. So remember, per means multiply. Competitor would be our variable. We can use C plus 3460. So that this particular expression for the straw bridge contest is going to be 550C for competitor plus 3460. Now the card tower one is going to cost $425 per competitor plus a 6460. So we can write an expression for that to be 425C plus 6460. So we have our two different expressions. We need to decide which contest to host. So we're going to need to see the cost for the two contests to be the same. Same meaning we need to make them equal to each other. So to write an equation to show that they're equal, we have our two expressions. We're just going to put an equal sign in between. So we have $5.50 per competitor plus $34.60 is equal to $4.25 per competitor plus $64.60. Now what they're wanting us to do is solve this. Now I'm going to talk about properties. We're not going to really worry so much about properties as we are the explanation and what we're doing when we solve this. So our original equation, we're going to go essentially through these 5 steps we talked about earlier. Our original equation, you might have to write a little bit small, it's kind of tiny. 550C plus 3460. 425C plus 6460. They're talking about the multiplication property of equality by multiplying each side by 100. This is not something you have to do. However, it's a very nifty little trick to get rid of all of these decimals, because if we multiply each of these numbers by 100, it makes the decimals go away, which is going to make your numbers just a little easier to deal with. So if we did multiply each of these by 100, we would end up with 550C plus 3460 equals 425C plus 6,460. Now, again, this is not something that you have to do. It just makes it a little bit easier. Later on, when we talk about fractions, this is going to be a really nifty trick to get rid of denominators. So if we go back to our steps at the top, there's no distributive property, and there's no collecting of like terms because we don't have any C's or regular numbers on the same side of the equals. So we're going to jump to number 3, which is move your variables to one side. Now when we move our variables to one side, we want to move this smaller if we can. It keeps us from having negatives. Move variables to one side. And again, we're going to try to move the smaller of the two. It doesn't have to be the smaller, but again, it keeps us from having negatives. So I have 425 C's, I have 550, so I want to move this. Well, it's a positive. Well, I'm going to do the inverse property of addition by subtracting 425C. Remember, in all things math, what you do to one side, you have to do to the other. And when I subtract these, I end up with 125C plus 3,460 is equal to 6,460. Now it looks like the equations you worked with a lot last year. So we're going to use our inverse property of addition, which is also known as undo the add subtract. So we're adding 3,460, so I'm going to subtract it again from both sides to show equality. So 125C is equal to 3,000. And I'm going to do the inverse property of multiplication, again known as undo the multiply divide. I'm going to do that by dividing, and I get that we have 24 competitors. So what does this mean? That means that we need 24 competitors for both contests to be equal or cost the same. Okay? So that being said, let's look at another example on the back, or let's expand on this example. So what does the meaning, they say X, we use C. So what did C represent in the context of our problem? Well, C was the number of competitors. For both contests to cost the same. Now we talk about we have more than 30 competitors in the contest. Make a recommendation to the club explaining which contest would be a better choice. Well, so now we're saying, what if we said C equals 30? So if we plug this in for the Strawbridge competition, so we're going to say $5.50 times 30 plus 34.60. We're going to see how much that is. We're going to see how much it's going to cost for 30 people in the card tower contest. So 425 times 30 plus 64.60. So when we plug all of that in, we get that the Strawbridge contest is $199.60. Well, the card tower contest is $192.10. So based on that information, which contest would you recommend? Well, I would recommend the card tower. It's cheaper. It costs less to host. If they charge $10 to enter the engineering contest, write an expression for the revenue of X competitors to enter. Well, if it's $10 for each person, then the expression, remember, expression does not, let's write it like this, no equal sign. So we would just say 10 times, I'm going to use C because we keep doing that. You can write X. 10 times the number of competitors would be the cost, how much revenue, how much money they make. Write the equation to find the break-even point for the fundraiser using the contest you recommended. So what we're going to do is we know that we have 425 times the number of competitors plus 64.60, and we know that we're going to make $10 for each of those. So how do we break even is another way of saying for them to be equal. So 10C equals 4.25C plus 6460, and then they want us to go ahead and solve this like we did on the previous page. Now, again, going through those steps, we don't have any distributive property, we don't have any collecting like terms, but we do have variables on both sides. This 425 is smaller than 10, so using the inverse property of addition, I'm going to go ahead and move it over. 10 minus $4.25 is $5.75 per competitor, and we still have $64.60. Using the inverse property of multiplication, we will see that this actually comes out to 11.23, and it's going to keep going. So we need to decide, you can't have 0.23 people. 11 people is not going to break us even. So we're going to have to round to 12 competitors, because it's better for us to be too much than not enough. How much profit would we earn from 32 competitors? Again, we're simply going to plug this 32 in for our C up here. So 10 times 32, that means we're going to make $320 from their entry fees. And then we have $4, I'm sorry, I didn't mean to put an equals here. $4.25 times 32 people plus 64.60. This is how much it's going to cost for us to put on the competition, which is going to be $200.60. So if we want to know a profit, if you look over here, your profit is your revenue, which is the money that you make, minus the cost. So if we do 320 minus $200.60, our profit for the contest is $119.40. We're going to review this some more in class tomorrow. I hope you have a great night.